Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 109 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. Now, in this class, moving forward, we are going to begin to do more things where we want to operate our Raspberry Pi Pico project remotely. Now, there's going to be two parts of that. One part of it is to communicate with the Pi Pico over Wi-Fi. So upcoming, we've got lessons on how to set up a simple client-server relationship between a program on your PC and the program that is running on your Raspberry Pi Pico W. And the second part of it is if you want to be completely remote, you need to be able to power your remote project. And that's what I'm going to talk about today, because in this class, we're going to be doing some stuff, in the future lessons. In this particular class, we're going to be giving you the opportunity to operate remotely. And then there's an upcoming class that's just getting started where we're going to have a GPS project connected to a GPS connected to the Raspberry Pi Pico W to make a GPS tracker. In that case, we really have to operate remotely. And so I'm going to show you the kind of things you need to understand so that as I start going through these lessons, you'll understand why things are unfolding the way they are. And so first of all, I will be using to power remote projects the Sunfounder breadvolt. There is a link down in the description. You can get this, and this will be used on our future, on a lot of our future lessons. You might go ahead and order that. And then in today's lesson, I'm going to kind of tell you how to use it. So then as you're watching those other lessons, you understand why I am doing things the way I'm doing them, and I won't have to stop at each point and re-explain all of this. Sound good? Okay, I hope it does. And so let's jump in. Let me get out of your way. And then what I need to do is I need to have you guys build a simple circuit so I can kind of demonstrate this concept to you. And what I will, boy, got an ad popping up on me there. Okay, I'll need you to go to the most excellent www.toptechboy.com, and I'll need you to use this happy little search icon and search on something like powering your Raspberry Pi Pico W from battery for portable operation. Okay, and then I have a very simple circuit here for you to build where I have a blue LED that is connected to the power rail, so it's going to be on all the time, and a red LED that is a simple toggle switch. Okay, now we've done this a lot in this class, and so I've gone ahead and just given you the code so we don't have to take the time to develop that code, because we've done a lot of this in earlier lessons. So go ahead and hook up this circuit, and then let me get this code, and I will copy the code, and then I will come up to Donnie, and I will create a new program. Okay, and I will paste that in, and then let's come over here and let's see if we can get a view. Let me see if I can get a view that would show all of the things that you need to see here. I think this one will do it. All right, so this is my circuit. This is my code. You notice that the blue LED comes on right away because it's connected directly to the power rail. Okay, also, what I want you to notice is that the power rail is receiving its power from the Raspberry Pi pin 36. Okay, it is receiving its power from the Raspberry Pi pin 36. Okay, pin 36 is a 3.3 volt output pin. Okay, so where is the Raspberry Pi going to get its power from? From the 5 volt USB cable that you have plugged in right here. Now, it goes through some circuitry magic, and when it comes out this pin 36, it is going to be 3.3 volts. Now, why do we need that? Because in this particular case, I have the blue LED on all the time. Where is it getting its power? From the power rail that is getting its power from the 3.3 volts. Pin 36 is an output. It's outputting 3.6 volts, 3.3 volts, and it is turning the blue LED on. Now, if we were not running this blue LED, we wouldn't need that connector there. All right, but let's go ahead and get the code, and then let's come back over here to Thani, and then I pasted the code in. Let me make sure I'm connected, and then let's run this thing. Okay, there we go. We run it, and now the blue LED is on, and I've got a simple toggle. Toggle on, toggle off, toggle on, toggle off. Okay, that is very, very neat. All right. Now, what if I wanted to operate completely remotely? If I wanted to operate completely remotely without this USB cable, what I need to do is I need to get rid of this. Okay, and now I need to save the program as, save as, on the Raspberry Pi Pico. Program's running. Let's stop it. Oh. Save as Raspberry Pi Pico W. I'm going to save it as main.py, like that. Okay? Yes, I want to overwrite it. Now, what's going to happen? What is going to happen now is if I unplug this, okay, now it's not working because it doesn't have any power. But if I plug it into power and give it a second, now it's working again. Why? When the Raspberry Pi Pico boots up, it automatically runs the program main.py. Okay, it automatically runs the program main.py. So that's the first thing. You've got to have your program that you want to run remotely. You have to have it saved as main.py. But now let's say I disconnect this and I want to run from this portable power supply, this breadvolt. Now this is what we have to consider. We have to consider that I need to power this blue LED and I need to power the Raspberry Pi Pico W. Okay, now powering this, you could say that's really easy. All I do is just plug it in, and I could set this with these jumpers either to 5 volts or 3.3 volts, and I could power the thing up. That works for the LED, but you got to remember that we have the power rail here. We have the power rail connected to the output of the Raspberry Pi Pico W. And so now if I just plugged this in here, what problem would I have? The breadvolt would be trying to tell the rail what voltage it should be, and pin 36 is trying to tell the rail what voltage it should be. And so we've got two voltage supplies connected together, and that is never a good idea. And so what we would need to do is we would need to change this circuit, and we would need to come down here. And what we would need to do is we would now need to think, I am going to use the breadvolt to not only, I'm going to use the breadvolt to not only power the LED, but I'm also going to use it to power the Raspberry Pi Pico W, which means that the Raspberry Pi Pico W needs to not send power to the rail, but get power from the rail. And you can get power from the rail by connecting the Raspberry Pi Pico W to Vsys, which is pin 39 here. Okay, now I can power this thing with this. All right. So what do I need to do? This, okay, is connected to pin 36. So what I need to do is a little magic here, and I need to connect it to, pin 39. You see, like that. Now, if I come in and plug this in, okay, like this, and really, you've got to be very mindful also of what you have this set to. You see, right now, I have got it set to 5 volts with those jumpers in that position. If I put the jumpers here, it's going to set that rail to 3.3 volts. But remember that this Vsys, I say remember, but I will tell you, the Vsys says that it will power the Pico W if you're anywhere between 1.8 volts and 5.5 volts. So that's saying that I could run this at 3.3 volts, or I could run it at 5 volts, and either one of those should power the Raspberry Pi Pico W, okay? And the LED isn't going to much care whether it's 3.3 volts or 5 volts. But let's go ahead. I'm going to set it at 5 volts, okay? I'm setting it at 5 volts there. And now I'm going to come in and I'm going to turn it on. We've got the LED on, and then boom, it is operating. Why? Because I am powering the Pi Pico from pin 39, which is getting its power from the rail, which is set at 5 volts through these pins here. Does that make sense? Okay, let's just see. I'm going to turn it off, and then I'm going to come in here, and I'm going to put it at 3.3 volts, and I predict this also is going to work. Okay, the LED is happy, and it is toggling. If you look closely, probably the LED is not quite as bright. The LED is not quite as bright, all right? But then that is working absolutely fine. Now, this is the million-dollar question, okay? As I am doing development in the future lessons, I'm going to want to be showing you remote operation, okay? Let's look at it, remote operation, okay? But then I'm going to need to edit the code. I'm going to need to come back, and I'm going to need to edit the code. Now, what do we do if we need to edit the code? Okay, well, we need to plug the USB back in. Now, you might say, okay, turn it off, and then take this back and put it the way it was. Okay, but I'll tell you a little shortcut. You can just turn it off and then plug it in. You can turn it off and then plug it in. Now, what is very important for you to see is, even though these lights are on, this is not on. The switch is off. So the power is coming from where? It is coming from the Vsys pin. So now the Vsys pin, sort of in the little bit of time while I am downloading the code, the Vsys pin is a little bit acting like an output pin. But I can do this, and I can plug it in without any real risk because this is off. I am not trying to set the rail from this and this. It's just the power is coming from the USB to pin 39, lighting the LED, and then kind of lighting up this breadvolt. But it is not really on. Okay. Now, in future lessons, if you see me going through the lessons and you see these lights on, you don't assume that this is on, because I will not turn this on when this is plugged in, okay? But if you just look at the videos as I'm going through it and I plug this in and you see these lights, you might think that I have them both on at the same time, but I will not turn them both on at the same time. Now, if I was really doing a project and I was not using this, I would connect this to pin 36. I think that's the cleanest way to do it. But for the few minutes while we're downloading the code, let's come back over here. Let's download the code. Let's get to the Thani. Okay, so you see I've got the breadvolt connected. I've got everything on, and then I can come over here and I can download the code, and then you see this works. All right. Now, if I unplug it and turn it on, it works. Okay. I would not, do not plug this in with this on. I'm going to turn it off. I'm going to plug it in. And then it works like that. So if we connect Vsys to the power rail that is powered from the breadvolt, everything works. But just don't turn this on while this is plugged in at the same time. Now, what voltage are we actually getting from here? Now, we talked about the pin 36. We talked about pin 36 is providing 3.3 volts. Well, this Vsys is connected to the USB through a diode, and that diode is going to have about 0.2 of a volt voltage drop. And so as this is plugged in, it goes through a diode. It gets a 0.2 volt voltage drop about before it gets to Vsys. And if we measure Vsys, we're going to be seeing about 4.8 volts. All right. Now, the thing is, though, remember, when I hook it up like this, it's because I want to operate like this. Okay, turn it on. Now, some of the components you might plug in here, they might not work at 4.8 volts, but that's okay, because when you have it plugged in, you're not trying to operate, you're just trying to download the code. Then you take this off, and then you turn this on, and then if your component, maybe your SSD 1306, maybe it wants 5 volts, not 4.8 volts. It's going to work because it is getting 5 volts from here. Although right now I've got it set at 3.3 volts. So I'll put it back at 5 volts. Okay. Does that make sense? So let's talk about these 3 pins and make sure that you understand them. The VBUS, which is pin 40, that is pretty much just directly a connection between the voltage on your USB and the pin 40. Okay, so you could use that as an output, right? You could use that as an output, but it's not going to work once you take this off. Okay, if you're going to leave this plugged in, you can create a power rail through pin 36, okay, and that'll give you 3.3 volts. Now, if you wanted 5 volts and you aren't going to be operating remotely, you could just plug the power rail into VBUS 40, and then you would be establishing the power rail almost directly from this cable, okay? But what are we going to be wanting to do? We're going to be wanting to run remotely at something close to 5 volts. And so what we're going to do is we're going to establish that power rail using this, and it is going to be 5 volts. Now, if I want to download the code, again, what do? I turn this off, and I can leave this plugged in, and I can turn this on, and there's not going to be any concern of damage because this is switched off. Okay, does that make sense? Tell me what I would not want to do now. I would not want to turn it on. All right, some people say that really because there's a diode in there, and because there's a diode in there, that's going to provide isolation so that you could leave this on and have that plugged in. And it's probably that's going to happen a time or two when I'm teaching in these future lessons. I'm gonna plug this thing in and forget to turn it off, and that's just bad practice. And normally I don't do that, and so just don't do that. All right, so you unplug it and then you turn it on. Okay, guys, let's review what we've learned. Pin 40 connects directly to the USB, and you can power your power rail if you want 5 volts from VBUS. Okay, if you want 3.3 volts on your power rail and you're not operating remotely, what do you use? You use pin 36. All right. If you want to operate remotely, then you do not connect. You've got to power the Raspberry Pi Pico W. You power it through pin 39, which is Vsys, and you get the power from the power bank, and the power bank can operate at 5 volts or 3.3 volts, and the Pi Pico is going to be happy getting 3.3 volts or 5 volts, and the LED is going to be happy getting 3.3 volts or 5 volts. Now, why am I giving you so much detail on this? Because as we move forward, and we're going to be moving forward doing a GPS project with this Adafruit Ultimate GPS, and the thing about this is this has a V in that will take 5 volts, and it also has a 3.3 volt input. And what I have found is this module, for whatever reason, has a trouble getting a fix in finding the satellites if I'm powering it at 3.3 volts. So what will I want to do on this project? I will want to plug this in. I will want to power it from the power rail, and I will want to set my breadbolt at 5 volts and supply that power rail with 5 volts from the breadvolt. And then that will also power the Raspberry Pi Pico W through pin 39. Okay. And then what would I do? I would turn this off, and I would plug this in. And when I turn that off and plug this in, then I would be operating this with power that is coming from Vsys. And that Vsys is going to be about 4.8 volts, and that's going to be enough to run the GPS. Okay. And if it's not, then what would I do? I would move this over to this pin 40, which would be the 5 volts coming from the USB. But what I find that I'm going to be doing on this project moving forward, I'm going to have this set at 5 volts. That is going to power the Raspberry Pi Pico W through pin 39, and then it's also going to power the GPS through the power rail. And then if I plug in this in order to download code, I'm going to turn this off first, and then I'm going to plug it in, download the code, and then take it out and then turn this on. Okay. Or I could just leave this plugged in, and in that case, this Vsys is acting like an output, which will provide 4.8 volts to the GPS. Okay, does that make sense? I just want to make sure, because as I'm trying to get through these lessons, I need to make sure that you're understanding what I'm doing as you see me turning things on and off as I'm plugging things in and out. Okay, guys, give me feedback. And if you do not understand what I've talked about here, make sure to leave questions in the comments, and I'll talk to you in more detail, okay? Because this we really need to understand, because you do not, as we move forward, want to turn this on while this is plugged in, okay? You want to always unplug it to turn it on, turn it off to plug it back in. Okay, guys, I hope you all are having as much fun taking this class as I am making it. Really excited about the next lessons in the Raspberry Pi Pico class, where we're going to be doing some portable projects. So what I've just described is going to be important, as well as our new class on the building a GPS tracker. That's going to be real important for the new class as well. So this is a pretty important lesson. Okay, guys, I appreciate you watching the video. You can help me by giving me a thumbs up and leaving a comment down below. That will help with the old YouTube juice. Also, if you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.